All right, so we're going to finally finish this up. It took us 3 days to do one lesson, but we'll finally finish it up. So we're just dealing with angles today. The last thing we did, according to you guys, was perpendicular lines, correct? So that's on there. It's in your notes. I'm not even going to talk about that. Here's the next one. So we said we're going to do angles, and that doesn't even look like an angle, does it? But what if I put a point right there? So basically, I got two rays back to back, don't I? Okay, opposite rays. They're opposite rays. One's going this way, one's going this way. So what do we? How did we define an angle? As two what? Two rays with a common endpoint. Okay, which is called the what? You guys ready? 3 right there. All right. At the end of the market period, I do this every market period. At the end of the market period, I am changing seats. So I'm making sure that I know who I'm not going to put next to who. All right. So some of you guys, for sure, you're not going to be next to each other, just so you know. All right, let's keep going. So I got two rays with a common endpoint. So what do I have? No, just tell me what I have. Just simple. Look, if I got a ray here and I got a ray here, what do I have? Yeah, I got an angle, exactly right. Okay, two rays, common endpoint. What do I have here? Two rays, common endpoint, right? So what is this thing? It looks like a straight line, and it is, but it's also what? It's also an angle. That's right. Okay, and you're exactly right. Since it's a straight line, look at that. How many degrees is that? It's 180 degrees, right? You've heard that all the time, right? I don't know if you guys are into skateboarding or stuff like that. My son's a scooter rider. Well, he used to be. He hasn't done it in a long time. He actually went to California, into San Diego, with a bunch of guys for scooter riding. I mean, some of the guys, he's not, but some of the guys are like professional, I'll put that in air quotes, professional scooter riders, because that's how they made their money. They would go to different places. My son, what he did, he didn't compete. The other guys competed and stuff, but my son would video and take pictures of those guys. So they go to like the streets of San Diego, the streets of LA. They went to Philly. They went to all kinds of places, and they would have these big scooter street jams, is what they call them. And like hundreds of kids on their scooters would, or just people with their scooters would get on the streets. And my son would, so he would film them, put videos, put them on YouTube and all that kind of stuff, put them on their website and all that kind of thing. So doing a 180 is something that you hear a lot, but more than just a 180, right? They do 360s, they do 720s, right? If you ever watch the Olympics, snowboarding and all that, they use those terminologies all the time. Even preachers use 180. Have you ever heard somebody said, you need to turn from your wicked ways, okay? You're going this way, you need to make a what? 180 degree turn in your life. You ever hear anybody say anything like that? I've heard it, all right? So they say turn 180 degrees. What does that mean? It means you're going in the complete opposite direction. I've actually heard a pastor one time said, he was doing that whole thing, right? You got to change from your wicked ways. He says, you got to turn your life around 360 degrees. And I was like, whoa, what does that mean? If I turn my life around 360 degrees, then where would I be going? In the same direction that I was going before. Don't think that's what he intended, right? But I've heard that, and like whoever I was next to, I think I elbowed him. I'm like, 360? I think he meant 180, right? He's got to take a geometry class. Anyway, so 180 degrees. And this is a straight line, and it is an angle. Why is it an angle? Because they got two rays with a common vertex, all right? And so we call this a straight angle. So it's a straight angle. A lot of talking just to do that one little thing right there, but that's okay. All right, so that's a straight angle, 180 degrees. And that's really important. I'll tell you what, let's do one other little example with a straight angle. All right, so let's say the vertex is right here, and then you got another angle coming out of it. All right, everybody see that? I didn't do this with the other class. I should have thought about it. How many angles do I have here? Why 3, Ben? Just because I was waiting for you to say another one? Is that okay? Penny, tell me why. So you got these two right here. Those are the obvious ones, right? I'll call that angle 1. I'll call that angle 2. Where's the third one? The straight angle. Exactly right. Okay? So you got this is one angle. This is a second angle. But you also have that whole thing right there. We'll put a 3. So you got 3 angles there, don't you? All right? Let me ask you this. What if I said, get rid of these numbers. What if I said that this was 50 degrees? This angle right here, that one was 50 degrees. And then I'll put an X degrees right there. Then what is this angle right there?
That's 130.
Why 130? How'd you get that? That's right, because they have to add up to be what? 180, because they make a straight line, a straight angle. You with me? You're going to be asked this kind of stuff, all right? So look, the whole entire straight line or the straight angle is 180 degrees. They tell you this is 50. How do I find out what's left over? I subtract. So I go 180 minus 50, which is 130. So X is 130 degrees. That's the kind of stuff they're going to ask you to do. That's the easy stuff they're going to ask you to do. You know what they're eventually going to do? They're going to say like this is 2x plus 1, and they'll say this is like 3x minus 2 or something like that. Okay, I don't know exactly what works out, but what would you do with this? What would you do with this and this? When you say put them together, what are you doing? Mathematically, what are you doing? You're adding them, right? You're adding them together, all right? So you would take this angle plus this angle and set it equal to what? 180 degrees. I'm not going to do it because I don't know if this comes out nice or not. It probably doesn't come out real nice, but that's what you would do, all right? I'm sure they'll have a problem like that on homework or something, so you can work on that. All right, but that's what we're going to do with straight angles, so keep that in mind as well. All right, let's do another one. Let's talk about, let's draw, we'll just draw it like this. All right, there's an angle. I'm going to group it, and then I'm going to copy, and I'm going to paste it. So I copied and pasted. So what do you think might be true about both of these angles, the degree of both of these angles? Yeah, they're the same. If this was, I don't know, I'm just making this up. If that was 60 degrees, what's this one right here? That's going to be 60 degrees because I copied and pasted it. They're exactly the same measure. Now, let me ask you this. Are they exactly the same angle? No, because this angle is over here to the left. This angle is over here to the right. Okay, I could even like twist it. Oops, let's try it again. I could even twist it a little bit. Is it the same degrees? Yeah, it's the same degree measure, all right? But they're two different angles, agreed? All right. So, let's do this. We don't say the angles are equal to each other. Now, this is a subtle difference in geometry, okay? So listen carefully. We don't say the angles are equal to each other. We could say that the measures of the angles are equal to each other. And in fact, they do this. Let's call this angle A and angle B. All right? There's only one angle coming out of there, so I can just name it by its vertex. Same thing with this. Here's what the book does. It says the measure, they use a little m to mean the measure of angle A is equal to what? What is the measure of angle A? 60 degrees. Okay? You'll see this in the book. I don't make you write that. I probably will not write that on a quiz or a test or anything like that, but you will see this in the book. You'll see this in most books. And to tell you the truth, a lot of geometry teachers would probably frown on me not putting the M there. A lot of times they do that. But to me, it's just a waste, all right? I could just say angle A is equal to 60 degrees, or the measure of angle A is 60 degrees. What could you say here? The measure of what? Angle B is 60 degrees. So if two angles have the same measure, we don't say the angles are equal to each other. We say the angles are, we've used this word once, congruent to each other. That's right. So these would be considered congruent angles. All right? So how would I write it? I would say that angle A is what? Yep, congruent, that's their symbol for congruent, to angle B. We don't have to say the measure of. When we use congruent, we don't put measure of. All right? If I said the measure of angle A is equal to the measure of angle B, that means that 60 equals 60, all right? But if I just said, are they congruent, right? If they told me they were congruent, how do you know if they're congruent to each other? If they put a little arc. See that arc right there? If that has one arc and that has one arc, that means that those angles are congruent to each other, right? So we're going to be using that. I know you're probably tired of hearing me say this, but it's absolutely the truth. We're going to be using that kind of thing all book long, okay? The rest of the year, we're going to be talking about angles and different things. We're even going to talk about triangles that are congruent, segments that are congruent. We're going to talk about all kinds of other things that are congruent to each other, all right? But that's the start of it. All right, let's do another one. I think this is where in the other class I'm picking up on. So now we're caught up. Let's do this. Let's go here. Let's go right there. All right, how many angles do I have here? I got 3. I got this one. I got this one. Where's the third one? The whole big angle. That whole big angle would be the third angle. Everybody see that? So I just want you to make sure you know how many angles there are. Let's name them with some letters this time instead of using those numbers. So this is M. This vertex is N. We've got a point on this ray, which is K. And this one is P. All right, we're gonna talk about this word. I'm just gonna give the word to you. It's called adjacent. Has anybody heard that word before? Yeah. People actually use that word in regular conversations. Not necessarily talking about geometry, but so you'll hear people, kids don't usually do this. I mean, I don't hear this in high school too much, but when people get to be adults, they'll talk about where they live. They'll say, like, I live next door to somebody, or you could say that their house is what to my house? Adjacent to my house. That means what? Right next to it, exactly. It means next to, all right? So that's what the word adjacent basically means. So what I want to do is find out which angles are adjacent to each other, which angles are next to each other, all right? Tell you what, just to make this a little easier, instead of using the letters, let's put a 1 and a 2 right there. Is that all right? Okay. So very easily, tell me which angles are next to each other. 1 and 2, that's right. So 1 and 2 are what? Adjacent angles, okay? They're next to each other. Now, they give you a couple things in the definition of adjacent angles. 2 things must be true, all right? The 2 angles, in order to be adjacent angles, I'll tell you what, let's put it here. In order to be adjacent angles, 2 things must be true. They must have a common side, okay? So they must have a common side. Oops, it's terrible writing. Common side. But no, and I'll explain this in a second, but I'm going to write them down right now. No common interior points. I'll just put PTS, points. What in the world does that mean? Well, I'm glad you asked, because I'm going to tell you. So first of all, you said 1 and 2 are adjacent angles. So they have to meet both of these criteria. They have to have a common side. What is the common side between angle 1 and angle 2? What ray, that's a side, what ray or what side do they have in common? Can't just say K, because K is not a ray. You got to say it as a ray. Ray NK, that's how you say it, okay? It's ray NK. Do you see that one right there? Tell you what, I'll make it a different color just so it stands out a little bit, okay? That one right there, all right? That's your common ray. Angle 1 has that as a side, doesn't it? Angle 2 has that as a side. Agreed? What about NM, ray NM? Is that common with both of the angles? No, it's in angle 1, but is it in angle 2? No. What about NP, ray NP? Nope, it's in angle 2, but it's not in angle 1. Everybody got that? So that's the common side. That's pretty easy to see. The next one's kind of weird. It says it has no common interior points, which means this. If I put a point in the interior of one of the angles, is there any way that it's going to be in the other one? Ben, I moved yesterday. You know, where your next move is going to be, right? Take a wild guess. First of all, you're sitting in the seat you're not allowed to sit in. Okay, you got to be in a chair, in a desk. So get in the desk, get out of that chair. I told you before, all right? And you know, you were just hoping I wouldn't say anything. Next move is to the office. All right, here we go. Let's do this again. Is this point in both of these angles? No. I could put a point anywhere in the interior of this angle. Is there any place that I could put a point in angle 1 that will also be in angle 2? No. You think, well, maybe right on it, right? Like K, that's part of angle 1 and angle 2, isn't it? But is it in the interior? No, it's right on the angle itself. It's not the interior. All right? What about the other angle, angle 2? Can I put any points here, 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 where it's going to be an angle 2 and it's also going to be an angle 1? Nope. So does it fit these two criteria? It does. It has a common side, so check. Does it have no common interior points? Nope. Doesn't have any ones that are in common. It doesn't share any common points, so we check that. Are they adjacent angles? Yes, they are. Okay. Now, some people might say, let's go to a different color. Some people might look at the whole big angle, which is what? M, N, what? P. That whole big angle. Just to make it easy, I'm just going to call it angle 3. Is that all right? It's a lot better than saying MNP every single time. All right, so is angle 3 and angle 1 adjacent angles? Well, let's go through the criteria. Do they have a common side? Look at angle 3. Do they have a common side with angle 1? Yeah, which one? What side's in common? N what? NK? NM, right. This one right here is definitely in common with 1 and 3. But look at this one. Does it have any common interior points? So if I put a point here, that's an angle 3, right? MNP. But it's also where else? In angle 1. So it does have a common interior point, doesn't it? All right. What does this say? It says no common interior point. So is big angle 3 an adjacent angle to angle 1? No. If they overlap, and that's what's happening, isn't it? Angle 3 is kind of overlapping angle 1, and it's overlapping angle 2. You see it? If they overlap like that, then they are what? Not adjacent angles. All right? I don't want to spend a whole lot of time on that. There's another topic that we're going to talk about later on where we talk about adjacent angles, but I don't think it's in this chapter. That's really the only thing you need to know for that right now. Let's keep going. I'll tell you what, let's keep this picture there. Forget all the dots. I'm not even going to get rid of them. I'll just keep it there, okay? Let's talk about this. They call it the angle addition postulate. And we kind of alluded to it already when we did that whole 180 minus 50 thing. We got 130. Postulate. Remember, a postulate is something that's accepted without any proof. Okay, you just accept the fact. All right, so a postulate, you just accept it. You don't have to prove it. What's the other one where you do have to prove? Not a postulate, but a what? Starts with a T. A theorem. Remember that? Okay, we talked about that a bunch yesterday. A theorem, you have to prove. A postulate, you don't prove. You just accept it. Do you remember the one we did up here? Right? That was 50. This was 130. Tell me something about that 130 and that 50. What do they do to make 180? They add up. That's right. So watch. This angle, right, plus this angle equals 180 degrees. Agreed? Look down here. Now, you don't have 180 degrees, but tell me something about angle 1 and angle 2. What do they do? Yeah, so angle 1 plus what? Angle 2 equals angle 3. Right? So if I knew that this was, 40 degrees, angle 1 was 40 degrees, and I knew angle 2 was, let's say, 20 degrees, what is angle 3? Everybody watching? Trey, you with me? I said, If I have angle 40, angle 1 is 40, angle 2 is 20. What is angle 3? So angle 3 equals what? 60 degrees. How did you get it? You went 40 plus 20, and that's 60 degrees. All right? So these two angles, this angle 1 and this angle 2, combine together to make big angle 3. So that means they add together to be angle 3. That's the addition postulate, the angle addition postulate. You're going to do that a lot. You're going to see two angles that are next to each other, adjacent angles, and they add up to be the whole entire angle. All right, we're going to use that a lot. And again, like we did on the other thing, it's not just going to be easy numbers. What do you think they're going to throw in here? They're going to put some x's in there, right? Some variables in there, right? It might be 5x minus 2 or 2x plus 1 or something like that, right? And you're going to have to add them up and then set them equal to what the whole angle is equal to. All right, just keep that in mind. It's very, very important. With all that said, let's do an example that we use that stuff. All right? Got to stay awake for this. This is super important because you're going to have questions on a quiz and a test on this stuff. Let's see when we get out of here. 38. Oh, I got time. Good. I thought I was running out of time. So I only got to do this one example. This is example 4, and I hope you're paying attention. I hope you're writing it down. Okay, be students. Okay, be good students. If you don't have anything on your desk and you're not writing any of this stuff down, you're not a good student. I'll tell you right now. All right. If you're a good student, and if you don't have your notebook, borrow a piece of paper from somebody else. I'm sure they'll let you. If you don't have a pencil or a pen, I'm sure somebody has an extra that you can borrow. There's no excuse not to be writing the stuff down that I'm writing down. Because I can guarantee, I see it over and over and over again. It's the kids that don't take notes, that don't pay attention in class, that sleep in my class. They're the ones that fail my quizzes. They're the ones that fail my tests. They're the ones that are going to fail this class, okay? I see it over and over and over. Rarely, if ever, do I have a kid that's always taking notes, that's always doing their homework and doing what they're supposed to do, fails my class. That rarely ever happens. It's always the ones that don't do what they're supposed to be doing. So let's make up your mind, all right? You don't want to fail the class. You don't want to take it over again. And you know the ones who usually cry to me at the end of the marking period or at the end of the year asking me for extra credit and all that kind of stuff, they're the ones that aren't doing anything in class. I'm not giving you anything extra if you haven't tried to do what you're supposed to do in the first place. All right, enough talk. Man, I'm on a roll, aren't I? All right, so write this down. And the reason I'm so passionate about it is because I see it so much. I see kids that could be doing well. They're smart kids. They're bright, but they just don't do the work. All right, so let's do the work. Sound like I'm ready to preach or something. All right. Why did I put those two red marks right there? What's that? It means they're congruent to each other. I probably didn't draw it exactly congruent, but they're congruent, all right? If I measured these, it looks like angle 2 is a little bit bigger than angle 1, but if I put the arcs right there, that means they're equal to each other. So whatever angle 1 is and whatever angle 2 is, they are the same. All right, now here's what they give you. It says, here's the question, and this is the kind of stuff you're going to see on the homework, you're going to see on a quiz, you're going to see on a test. Find angle 2 and angle BAD. If you look in the book, they put a little m in front of it. What does that mean? The measure of the angle. To me, it's just a waste of time to write that. You know what I'm trying to find. You're trying to find not just angle 2. You're like, oh, there it is. There's angle 2. I found it. No, that's not what they are asking you to do. They're asking you to find the measure of the angle, all right? How many degrees is it? That's what they mean by the measure of the angle, all right? And they got to tell you one more thing, because if there's no way you could tell what each one of those are with this information. But if they tell you this, and they say if angle 1 equals 55 degrees. Now, one of these is super easy to find without doing any math whatsoever. Hopefully you see it right away, because they want you to find angle 2. They're both 55, that's right. Angle 1 is 55, right? And angle 2 is equal to angle 1, and so it's 55. Everybody see that? That was the easiest one. The next one's not a whole lot more difficult. So if you want, sometimes I'll do this. I'll get rid of the number angle. So that's 55 degrees, and that's 55 degrees. The last thing we talked about was that angle addition postulate. This is where it comes into play. So it says, find angle BAD. Where's BAD? BAD. What are they asking to find? That whole thing. That's right. That whole entire angle. So what do you do with these two smaller angles? You add them up. Everybody got that, okay? So angle BAD, let's show the work. All right, what's the work? You didn't have to do any work here. It's just 55 plus 55, and what is that? It's 110 what? Degrees. And then always label it, all right? So angle BAD is equal to 110 degrees. Don't just put 110 degrees and circle that. Okay, put what it's equal to. Angle BAD is equal to 110 degrees. Same thing right here. Angle 2 is equal to 55 degrees, and that's it. Pretty simple, isn't it? Yeah. Now, they could have switched it around a little bit, right? They could have told you that the whole angle is 110. And what if they didn't tell you the angles were equal to each other? What if they give you that information? All right, so they tell you that that angle is 55 degrees. The whole thing is 110. How would I find this angle right here? You would subtract. That's right. So you go 110 minus 55, and that, of course, is 55. All right, whatever angle that is, CAD. CAD. All right, so they're not always going to ask you this exact question. All right, they could switch it around a little bit on you. And these angles aren't always going to be equal to each other. They may be different, right? But if the whole thing is 110 and this is 55, then this has to be the difference of those two angles. Make sense? All right. Go back and watch the video, okay? If you weren't paying attention, if you didn't take notes, I would suggest going back and watching the video. But of course, if you're not taking notes in class and I'm yelling at you, well, I'm not really yelling. You don't think I'm yelling, do you? Nah. I'm just encouraging you, okay, to take notes. If you're not taking notes, okay, I really doubt that you're going to go home and watch the video and take notes. So I'm talking to the wrong person. Anyway, I just don't understand why you can't take notes. Yeah. So I'm going to collect both of these tomorrow, all right? So part A was what, 1 to 14? And many of you, I hope all of you, have that finished already. Raise your hand if you got that 1 to 14 finished. Most of you should, okay? If you don't, you got another chance to do it. Just because of the whole locker fiasco. I don't know. 27 and 29. It's on the lesson plan. I gave you a lesson plan on Monday, okay? All that's on that lesson plan. And it's on facts, okay? And it's right here. So 1 to 14, that should already be done, all right? And then we're going to call this 1.5b, and you're going to do 21 to 28. And I also throw a few more in there, 34 to 45. That's probably more of the stuff that we covered today, all right? So this was already due. I didn't collect it because of the whole book thing and the locker thing, all right? But it's going to be taken care of today, all right? Get your locker. I said it already. 27 to 29. And just look up section 1.5. Why does it matter what page it is? Just go to section 1.5 and look for the problems, okay? So, but it is on pages 27 to 29. This might just be 27, I don't know. But they all are from either 27 to 29, all right? So this was already due. If you have it done right now, just hang on to it. I'll collect it tomorrow. I'm going to collect both of these tomorrow, okay? They're two separate homeworks. So make one 1.5a and make the other one 1.5b. Make sure you put that on the lesson. A few of you, I think, might have already turned it in to me. Stop. You've been crunching that thing the whole time. I thought you would finish by now. Okay, let me compose myself here. So there are two separate assignments, all right? On the top of each assignment, the first one should be 1.5a, the second one 1.5b. Don't just put 1.5. If you don't put 1.5a and 1.5b, I'm going to take a point off, all right? I'm telling you right now. All right, this is the name of one assignment. This is the name of the second assignment. They are both due tomorrow. Right, good? Probably not, because I get asked questions of things I say just like 2 seconds before. So just listen to me the first time. But that's why I repeat myself over and over again. All right, have that due, or have that ready to turn in tomorrow for me. I'll give you the rest of the class to work on it. You got about 8 minutes or so.